In this slide, we're going to cover the notion of coterminal angles. If you remember, a few slides ago, we studied how given an angle measure, how to construct a geometric angle. Right, so from a given angle measure, how to make a geometric angle. So just quick recap of that, of how that worked. We selected the vertex of the geometric angle to be the center of the coordinate system. We aligned the initial arm onto the x-axis. Then we took the point with coordinates 1, 0. Then we used the angle measure to travel a given distance using a given angle. Then we took that point and we used that second point to construct the terminal arm of our angle. So this is how we construct a given geometric angle from an angle measure. But if you recall, that construction was not unique, so it was possible to take two different angle measures and arrive at the same geometric angle. So the geometric angle was the configuration of the two rays. So how was that possible? Well, like this. If you take this angle here, that would be, in this case, I drew the second angle was the angle alpha plus 2 pi. So alpha plus 360 degrees. So if you do that, you're going to get the same geometric angle. So two angles are called coterminal if the corresponding geometric angles are the same, literally coincide. They have the same initial and terminal sides. So here we have to be super careful in distinguishing the two completely distinct and different uses of the word angle. So we are using once the word angle to measure the measure of an angle, and once we're using the word angle to denote a geometric angle. So once again, a geometric angle was a configuration of two rays and a vertex, and an angle measure was just a number. Okay. How can that happen? So here I've drawn a bunch of coterminal angles for you. So here's one angle, but you could take rather than using that angle, you can travel in the negative direction. There you go. Or you could take one angle and come around multiple times. So the set of angles coterminal with a fixed angle alpha consists of all angles obtained in the following fashion. So suppose I'm giving you an angle alpha and I'm asking you, find me all the coterminal angles. All you need to do is form all numbers of this form. So here's the number alpha. I gave you number alpha. And then if you want to find all the coterminal angles, what you need to do is add all possible even multiples of pi. So take the number alpha and add all possible even multiples of pi. So 2k here is an integer. So k is an integer. So 2k is an even integer. So you take alpha, and to alpha you add an even multiple of pi. So you add all possible even multiples of pi to the number alpha, and you obtain the entire set of coterminal angles. In other words, what you need to do is you take the number alpha, you write it there, and besides that number alpha, you take the number alpha plus 2 pi, then alpha plus 4 pi, then you write alpha plus 6 pi, and so on all the way to infinity. Alpha plus 8 pi. Of course, you don't write infinitely many numbers. After some point, you write ... And same in the opposite direction. You write alpha minus 2 pi, then alpha minus 4 pi, then alpha minus 6 pi. If you wish, we can include a few extra, alpha minus 8 pi, and so on, all the way to infinity. Of course, you don't write infinitely many numbers. You write ...